Hello everyone, welcome back to our channel. Today, we will be measuring the gap between the blade and the shroud, mainly focusing on the tip clearance. The geometry is of the outer air seal of a turbine. The seal helps to minimize the leakage of air or fluid from the high pressure side to the low pressure side, ensuring that the majority of the air or fluid passes through the intended path of the blade and contributes to the desired work output. We start by creating a 2D blocking with top-down approach. Create a single block using macro option. Insert blocks addressing each surface intersection as shown. Here we are creating a base blocking around each surface as can be seen around the blades. Remove the block corners which are lying outside of the domain. Also remove the blockages that are passing through the blade surfaces. Trim the blocks addressing wedge shape. Now, here we have multiple intersecting surfaces as per the geometric features. The intersection are of both types, that is, concave intersection and convex intersection. Select the faces in a group as shown and do a boundary wrap. This created an O type of blocking for each surface. Also notice that at every concave intersection, the H-type blocking is created to maintain the orthogonality. Now assign the block faces to the respective surfaces. Also, check the assignments to avoid mistakes. Checking the validity shows us that the topology needs the support services. But first, let us go ahead and generate an initial grid. In this grid, it is seen that it needs to be optimized for density. So let's balance the density in the topology. Once the density is balanced, we can also address the error message that was shown when we checked for the validity. that is also known as mildly severe singularity. For more information, please have a look at our video on mildly severe singularity. Create the corners at the intersection of surfaces. Link them to the other corners as created which extends outside of the domain, maintaining the 120-degree angle at the intersection and 90-degree at the another boundary where it intersects. Select these corners in a corner group and create a contourlet curve as shown. This will output the curves following the shape of the edges that we created, and these surfaces will act as a supporting surfaces for the intersection. Remove these corners once the support surfaces are created. Now assign the faces emerging from the intersection to these support surfaces. Do an internal wrap with insert on these faces which will split each face in three. Run the Ggrid. The grid looks to be better but still needs to be improved for the density, so we will again try to balance the density. Running the grid again after density balance gives us a smooth orthogonal grid. With a max skewness less than 0.6. Thank you for watching. If you like this video, leave us a like and subscribe to the channel for new videos. If you have any questions or any comments, feel free to leave it below. If you want us to post tutorials on any specific geometries, you could write to us on support@gridpro.com. Follow us on our social media pages. Links are posted in the description.